Quanto dura?
Un'ora più o meno, più domande, però potete fare anche un'ora in qua. Good afternoon, welcome everybody to this innovation talk. This afternoon we are at the Scuola Sant'Anna in Pisa, and the title of this innovation talk is Open Innovation from Lab to Market. The talk is one of the monthly event series organized within the framework of the InnoCore project. This is a project funded by the European Union involving 7 European partners, universities mainly. The goal of this project is to transform the research and innovation within the universities of the Alliance, connecting researchers, innovators, and other non-academic stakeholders in order to develop a common knowledge, and involve also the audience, the generic public, students, and the audience. This afternoon, I'm pleased to introduce Professor Alberto Di Minin, that is a full professor of innovation management at the Scuola Superiore Sant'Anna, and his main research interests are intellectual property management, international management. Together with Alberto Di Minin, there is Professor Nicola Vitiello, that is a full professor of bioengineering at the Biorobotics Institute of the Scuola Superiore Sant'Anna. So we can start, I think, and for those that are connected today via YouTube and other platforms, we'll also have some time at the end for questions. So please, I leave the floor to Alberto and Nicola for 1 hour, more or less. At the end, you have via chat, you can open the window in chat, and please make your questions, and Alberto and Nicola are here to answer. Thank you so much.
Monia, thank you so much. It's a pleasure to be here. Good afternoon, everyone, here at Scuola Sant'Anna, and wherever from you are connected. It's a pleasure to contribute to this network that is putting together so many researchers around Europe. I'm a professor of management. I work in the field of open innovation, and today what I'm going to do is to showcase a little bit what open innovation is about. But together with Monia, we decided not to organize this in a traditional upfront class, but considering who was the other speaker invited here today, we thought to turn this lecture and conversation on what open innovation is really about. And open innovation is about entrepreneurs, managers who seek inspiration from research and technology and drive to the market with courage, with entrepreneurship, their enterprise idea. And it is difficult to embody in a presentation what open innovation is about, or actually it is possible, but it is much better to do it if we are fortunate enough to be seated next to an open innovator. And my friend and colleague Nicola is indeed an open innovator. So what we will do in the course of the next hour is to go through various steps of the professional life of Nicola, and you will notice that I will try to reroute this conversation towards an idea of theory which meets practice, and in turn practice that informs theory, in order to make Nicola a little bit a living case study of this journey that is open innovation. So this is the idea, Nicola, if you agree with me. We prepared this a few times, so at this point, this is the point where you say, oh, Alberto, what a wonderful idea.
Yes, yeah, it's a nice idea, of course.
And so if we start off, I guess we need to dig a little bit deeper into the time when Nicola was a researcher, a pure researcher, building up his expertise and reputation in the field of robotics and then wearable robotics. Can you tell us where did it started?
Yeah, yeah. Thank you, Alberto. That's really a pleasure to talk about this start of a long journey, which started about 15 years ago. And of course, the topic that we will talk about is, as a case study, is wearable robotics, as the colleagues can see from the slides in a few minutes. And my start, as you say, this is science. So I am a scientist above all, and I started as a researcher with my PhD about 15 years ago. And the first chapter, okay, is about understanding what is the wearable robotics, because actually I am involved in this innovation process, but it's an innovation process in the field of the wearable technologies. So I think that many people know what robotics is. Okay, in some cases you can just go on any search engine and see pictures about robotics, but I'm not sure that everybody knows what wearable robotics is. And so if you do this exercise, you will realize that wearable robotics is exactly robotics, but are technologies that you can interact closely. So they are kind of garments, armors that you can wear, and that can have several kind of applications. And unfortunately, I say we have to compete with science fiction, movies like Edge of Tomorrow or EELISA show kind of exoskeletons that augment the human capabilities. But I must say that I'm a little bit more old-fashioned, because I was inspired when I was a child to work in this field by this movie, this cartoon. But again, as I said, we have to compete with the creativity of science fiction. But wearable robotics is something which is still far from what you can see in the science fiction, and is something that is a research field where you can essentially cover different application domains. And my innovation journey started from the rehabilitation robotics field. Okay, so essentially 15 years ago, when I started my PhD, I was involved in a team of experts of rehabilitation robotics, wearable robotics. But nowadays we know that wearable robotics covers several applications fields, ranging from rehabilitation to assistive robotics, to exoskeletons for workers, for fitness, for, of course, also for defense application, and prosthetics. It's a kind of, I would say, kind of research field where innovation is very, is quite straightforward. There is a lot of room for innovation in the field of wearable robotics.
Nicola, before you abandon this journey from inspiration to application, let me point you to one of the first enablers, maybe not in the chronological order, nor in terms of importance, that we discuss in class when we talk about open innovation. And so, as a first enabler of open innovation is indeed the journey from inspiration to application. I have a solution which is driven my science and technology discoveries. And this solution is good within a scientific journey. On the other side of the table, I have a problem, which is driven by my knowledge of the industry, my application, whatever area I am specialized in. Now, the bridge between what we call the problem solvers and the solution seekers is sometimes part of the technology transfer journey. You went very fast in telling us rehabilitation, but can you tell us a little bit more on how the science of robotics and biorobotics you were engaged with found a natural application in the application to this to real life circumstances?
Yeah, that's something that is, I would say you touched a very important topic, because the innovation in this field, I don't know whether then this can be applied to innovation everywhere, but in robotics and in wearable robotics, you have exactly these two parallel lines. One is the science strand, the other one is the, I would say, the end user or industrial strand, which means that at a certain point you need to produce knowledge, you want to verify new design principles, you want to explore new design principles, but then you also have to pull out from this enormous amount of knowledge exactly the solution. And today I would like to explore this process that you say is the technology transfer process is exactly what an innovator does. I think that in many cases, young researchers, my experience of course, my experience is that in some cases researchers believe that the technology is the solution. Mm-hmm. But actually the technology is not the solution. The technology is the enabler, okay? So in the last 1 year and a half, I'm telling to everybody that technology is 5 to 10% of the process. But then you need to know about the market. You need to know about the end users, the customers. And I like to use this expression. Innovation is a kind of cherry-picking process. So an innovator, in many cases, is a cherry pickers. So you have a bunch, a toolbox of design principles, pieces of knowledge, and then you have to collect cherries, and then you can prepare. I like cakes, so I will prepare with cherries my cake, but essentially the innovation process is kind of making cake in the end of the day after you have picked your cherries. And my experience is exactly this. I have essentially 2 chapters more. One is what I realized together with my research team in the university, facing complex challenges, and then how from this amount of knowledge, this bunch of knowledge, we pulled out a product. But then there is a surprise in the end, because, I don't want to spoil, but even when you believe that the process ends, actually is a new start.
Mm. And another aspect that we think, looking at outside, from outside your disciplines, another aspect which is very important to consider in this journey from science and technology to the market is the contamination of different technologies. So different science, different technologies with their own set of problems where you see that working on the technology is the solution. No? So you have a lot of people that are focusing on their own problems, their own technical problems, their own scientific problems, are contaminating to each other and are converging towards something else. So I know that in your journey, this convergence, and in the journey within your lab, you have multiple disciplines that are building on top of each other, to work on a greater problem. Can you tell us a little bit how was this possible, and what was the level of contamination between different disciplines that was necessary for you to begin your journey as a scientist, but also as an innovator?
Yeah, the point of this interdisciplinarity or in multidisciplinary approach, I must say that in the robotics field is quite a natural tendency. I mean, I would find hard time to imagine robotics as a non-multidisciplinary effort. But even though, so which means that in a team of roboticists, just to make it clear, you have engineers of with different specialties, like biomedical engineers, bionic engineers, mechanical engineers, electronics, and I mean, all the ICT domains are represented. But you also have to interact with psychologists, you have to interact with medical doctors, or with occupational medical doctors, or physiatrists. So it's a multidisciplinary effort. And in my view, what I have learned in this journey so far is that the difference, I mean, if you want to make innovation, and this is something that I could not imagine from the very beginning. I always had the wrong idea that you can rely on your effort, and then the more you do, and then the more you can get. But actually, this is not true. So you can do whatever you want, but if you do not have with you the right persons, which is a trivial, I mean, it's trivial in the end of the day. I mean, everybody may agree with me, but selecting the right persons is fundamental to advance the science, but is also fundamental to make that cherry-picking operation. So in this case, the role of the innovator is more kind of I like to make this parallelism with the football, because essentially an innovator is not that much different from a coach of a team, where look, there are football teams that are very strong and solid, even though they do not have extremely big champions. And there are also football teams that have a lot of champions, but they do not manage to win the Champions League. And the difference is in how they are put together. Okay, so an innovator has to be able to make this cherry-picking operation, but also, I like this expression, to federate the effort and resources. And in the journey that I want to talk about, this is exactly what happened. So I could not have reached the level of results acting as an individual, but I had to work as a part of a team.
So for those of you that are listening and do not know your story, let us walk our audience through the various roles that you played through your journey. So starting as a researcher, then as a founder of UVO, and then and now as an advisor to UVO. So I will try not to interrupt you because you're saying a lot of interesting things, but I'm taking notes. 5 minutes to explain the journey from your research to what UVO is now.
Yeah, I can be very quick because I don't want to make a long story. While working, I will show also some figures and just to substantiate a little bit more what I'm talking about. When I started my career, the driver at that time, but still is the driver today, is that the aging society is raising a lot of opportunities for new technologies to make the aging society more sustainable. And this was the driver for many activities at Scuola Sant'Anna. Now, look, I don't want to talk about all the things that I have explored in my 15 years of academic activities, but just focusing on one of the part of the activities, which is the exoskeletons for upper limb. And the message for everybody is that you will
again, the exoskeleton for upper
limb rehabilitation.
Upper limb rehabilitation.
Now, there are videos, you can see what I'm talking about. The point is that, and that's something that my message for younger students and researchers is, look, you will realize how the academic devices have a certain level of complexity, a certain level of ambition, and this was a kind of gym to understand how to then simplify the design to get a product out of it. Okay, so the first chapter is understanding the complexity and deal with the complexity. So there is no wrong, and I would suggest that this is important for everybody, in particular for those that work in the technology domain. I mean, you don't have to be worried about complexifying your research activity, provided that you know that maybe then the solution is in a simplified version of what you do. Just to make it short, I started with the problem of spasticity at the elbow, so how to invent devices to treat elbow joint affected by spasticity after stroke. We came with the first device that is called NeuroExos elbow model, which is still working in clinical trials at Scuola Sant'Anna. And this device was at that time used with patients in a first validation study, so I had to experience with regulatory framework to understand how to certify a device for investigational use. We have now running a protocol with a randomized control trial with patients, so this kind of technology is still there. I mean, I started 15 years ago with this device, and it's still used to make experimentation and producing knowledge, okay? After this device was developed, we came with other technologies to move from the elbow to the shoulder. And if you look at these devices, it's clear that the level of complexity of the device is increasing. Okay, so you have different versions. So, again, the scope is not going into the engineering details, but it's obvious that if I go from the left to the right, I can see the elbow joint, then the shoulder and the elbow, first version, and the second, and then the third. And every time there is an increase of complexity. Maybe we changed the degrees of freedom. We worked on the technology. These devices are still object of investigation, but we learned a lot of things. We learned how to cope with the human biomechanics, how the brain behaves when interact with a new system. We learned about humans. We learned about humans, which is very important if you want to come to develop a product that has to be able to interact with humans. So the first, of course, I mean, in this slide there are 15 years of career, okay, 15 years of people that have spent days and nights working on prototypes. And this was part of the knowledge from which we extracted the competencies, the human resources that then were able to design the product that I will talk about in a few minutes. So the first step is understanding humans, understanding and coping with complexity. Let me jump a little bit to, maybe I have prepared too many technical slides, but I mean, this is a kind of experiment, the one we are doing with this dialogue, but I want to go to one slide where there is a video which gives an idea of what does it mean interacting with humans, which is this. Hopefully it should work. Let's see. So this video shows the performance of a device, which is a very nice lab prototype. Okay, so you can see in this video how you can fluently interact with a machine, which is a wearable robot. Of course, this device is intended for rehabilitation purposes. So the fact that you can interact with the machine, and you see from this video that the machine follows your natural movement. Okay, now you can see this each individual joint was not for free. It took years in investigating biomechanics, so we were talking about multidisciplinarity. So here there is biomechanics, there is neuroscience, there is human movement control, there is mechatronics. There is a lot about how to interface from a cognitive and physical viewpoint with a machine. And even though this device is not yet a product, we learned how to make the jump. So you can see in my mind, I have this one strand where I do research with my colleagues in the academia. And then I try every time to understand out of this, how can I get inspiration, knowledge, how can I transfer knowledge from Scuola Sant'Anna to you. And this is actually something that happens through license agreement in the end of the day. And then out of this, you can develop product. Product means solutions to real problems, which is in a sense innovation. What does it happen? Sorry, what did happen at a certain point? While this strand of research was developing, on 2015 I raised together with other colleagues a spin-off company, Yubo, that then became part of at that time was Fiat Chrysler Group, now Stellantis, because we received an investment from Comau and Ossur to bring products on the market. And now the company exists, is living, it employs 20 people, and it is engaged in product developments project with different target domains like industrial, medical, and fitness, which is essentially what you see in this chart. So we have competencies and people to address 3 different market segments. And the product I will talk to you about today, not for marketing purposes, but just to show how the complexity was then addressed into a more simple device, is the upper limb exoskeleton for workers.
Okay, thank you for this walk through 15 years of research in research and innovation. There are a few steps we need now to emphasize as, once again, the enabler of an open innovation strategy. We talked about application, the seek for application, we talk about contamination. Let's now talk about the role of intermediaries. In setting up your company, you had to rely on expertise that was not in the market, that it was not in your scientific domains. That was expertise that helped you design your company, help you design your intellectual property strategy. You use the word licensing. Can you tell us what was the role of third parties in the development, the design of UVO? Where did you find this expertise, and why they were important to then, and we will then discuss later, reach an industrial partner, which is going to be the next chapter of our conversation. But let's now discuss about intermediaries. Who are they, and why do they matter for your open innovation strategy?
Clearly, an engineer cannot pretend to know everything. Okay, sometimes this is kind of mistake that some colleagues may do. I want to start from the conclusion of the answer to this question. The conclusion is that the secret is sharing your ideas and not be afraid to share your ideas. What I'm talking about is, when I realized I wanted to develop the company, I didn't keep it for me. I was not all the time spending the day. I want to make a company, I don't know how to do it, okay? Because this is not helpful, it's just useless. So in my university, in Scuola Sant'Anna, we have a very, I would say, strong attention towards technology transfer. So my first activity was, okay, let's talk about this idea with our technology transfer office, our professors in innovation managers. If you remember at that time, I started talking to you and to Professor Piccaluga about this idea. And then by talking, essentially by telling to other people your vision, you start, at least for my brain works like this, you start understanding more, you can understand what you need, and then you can share what you collect in terms of information with the other shareholders, and then you can brainstorm. And for instance, it was this incubation of the idea that lasted for about 1 year, starting from beginning to the end of 2014, that I realized that you need an accountant, you need to pay attention to safety, and then you need to study which one is the Italian law about safety, and you need to know about how a contract between a company and an employee works. All those things, sometimes you even don't know that they exist. But if you want to be an entrepreneur, you cannot avoid that. But at the same time, you don't have to pretend that you have to be an expert. Because in the design of a company, you know that you will pay experts. You will get suggestions, advice, consulting services for all those enabling functions for a company. You don't have to be expert of those things, so never pretend to know more than your accountant, but you need to at least know that some problems exist, okay? And try to understand as much as you can about the mechanicistic steps behind some decisions. And this is what happened, essentially. So I took time to understand about the major functions behind the company, and then by talking to people, interacting, without being too much jealous of the ideas, because this is also important. I'm not sure I answered your question.
Yeah, you did, and you're telling us indeed how the central, the open innovation journey is, for sure, almost by definition, it's almost a tautology, it is sharing. But to be able to share, in order to be able to share, we need to design the condition through which you are able to share. Yes. And you use the word, I was able to share my ideas. In this sharing ideas, what was the most important component? Trust or contracts?
Yeah, it's...
So more formal, to make, you understood my question, but to make it more clear to the audience. Sometimes we go arm's length and we need to negotiate very clearly the conditions. If I rent your apartment, it's very clear. I'm using your apartment for my living purposes, and I cannot sublet the apartment to others. And we specify, and it's possible to specify everything in the contract, who pays the bills, and maybe you pay the bills, or I pay the bills, and we can put it down in writing. And we can set out a very nice contract, and everything is clear. There is no need to trust each other. I have you direct payment for me every month, so it's very clear. In other situations, it's more difficult. It's more difficult, and we need to trust the partner beyond the borders of the contract. When we discuss about innovation, sometimes it's very difficult to codify everything, and contracts might not be the best way to go. So in your case?
I would say that there is, in a process, which is a complex process, okay? So not complex in the sense that there are many factors that you have to consider. As I said, you have at a certain point you reach the technology in your research, and then you are enabled to say, okay, from now on I can talk about and understand how to make the spin-off, and then how to transfer the technology. But then, before you reach the era of the contract, there is a kind of era in which you have to rely on a trust. So I would say that before you reach the publicus notarius and you sign the foundation, the bylaw that gives rise to the company, or before you sign the agreement between then the company and the technology transfer office of your university. I mean, in all those interactions, you have to rely on a trust. And I was very lucky. I mean, sometimes there are many people who say, in the life you have to be also a little bit lucky, okay? But what does it mean, being lucky? Being lucky can be that you buy the lottery ticket and then you win. This is kind of. Or you can be lucky because you meet the right persons. Okay, so in my life in my career so far, I have had always the opportunity to meet the right person. This is not rhetorical, Alberto. Okay, so you need to talk to persons that are there and they frankly tell you what they think. They can keep confidential the things that you are telling them. And of course, sometimes you can be lucky, or you can also say that you are a little bit good in selecting the right persons and the right persons to talk to, okay? But again, you cannot pretend, and this is very important, you cannot pretend that you make an innovation process with the certainty and the null risk, the risk equal to zero, that all the steps you do are covered by a contract, okay? That's impossible. This doesn't mean that contracts are not important, but there is a time for contracts.
There is a time for
Don't put the contracts too early in like a kind of roadblock.
Let us go, for the sake of time, we are over half way through the time that was given to us. In the next part, we will try to cover other enablers for the open innovation strategy. And another enabler, we discussed about intermediaries, but then you said it in your very fast review of your history, the role of industrial partners. So at a certain point, Juvo is now a spin-off company of Scuola Sant'Anna. Everything is clear with the technology transfer office. The intellectual property is more or less set. But then Juvo takes another very important step, identifying an industrial partner. I remember when it was still a secret which your partner was, and you were preparing me for something like big news. This is going to be big, Alberto. When it's going to come out, it's going to be big. And indeed, the industrial partner is another enabler of an open innovation strategy. Can you tell us exactly what brought to Juvo the contamination, going back to one of the other enablers, with a partner such as the Fiat Stellantis group and specifically Comau? What did they bring to the table that you did not have?
Yeah, I think that both industrial partners that are now involved in Juvo, so Comau and Ossur, they have brought, I would say, can I use this expression, but I'm not sure that it is 100% correct. So the innovator, intended like the professor that wants to be engaged in an innovation process, is more an entrepreneur, okay? While these companies brought to the table the management spirit, okay? So at a certain point, as I said, I had the opportunity to meet, on the one hand, Mauro Fenzi, that was the CEO of Comau at the time, and Dr. Christopher Christensen, that was the medical officer in Ossur. I presented them, and also the CFO at the time of Comau, Michelutti, that was a very brilliant person. I mean, these people understood the potentialities of the company, of the deal, of the technologies, and it's like they helped us to provide constraints to a big amount of energy. Because you can imagine, you have a big amount of energy, you feel that you want to destroy everything in terms of destroying the market, you want to be super successful. So young people with a lot of energy, and the corporate, the big industrial players can provide you with those boundaries that can help you in going in the right direction. Because the risk otherwise, and this is also something that, I mean, I don't want to be, I don't know if it's properly correct, but it's a way to mitigate the risk of failure. Okay, so this industrial coaching helps younger entrepreneurs to get a little bit contaminated by the management spirit. That's what they put on the table. Of course, on top of their capabilities of manufacturing, making strategic marketing, and blah, blah, blah. But mostly was about this.
And another important aspect in your story, and if we go back to the to the previous slide, is for sure enabler number 5, which is people. But I would like to have you talk about people in a way that you already somehow played with, that is the changing role of people. So the changing role of people and the changing hats of people in an open innovation journey. The scientist that becomes an entrepreneur who realizes is not the CEO, but is deemed to become something else. The industrial partner who is a client, but then realizes that the technology is enabling to do something else, and so therefore enters in a different type of partnership. Your chief scientist that at a certain point becomes too important for the company and decides to be something else in the company. The investor, which starts to be your VC, but then realizes that you need the managerial competences and becomes more of a manager than an investor. All these shifting roles, it's part of the open innovation journey. And I wonder if you can help us understand if this was the case in your story as well, or in the case of Yuvo, the scientist remained a scientist, the industrial partner was the industrial partner, the technology transfer office did their work, and it was a very clear-cut distinction of roles.
Yeah, it's a mix. Okay, so maybe I can start from me. I mean, I am a scientist. I was a scientist. I am a scientist, but I'm not 100% sure I will be a scientist in the future. So the change of the role has not to be something that makes people worried. Okay. For sure, in our journey, there were some pillars that, as you said, was the technology transfer office for sure, and our industrial partners that were entered in the journey as a shareholders and customers at the same time, because as I said, Yuvo design and develops products for them, but we had also some people that changed the roles. Majority of the Yuvo employees were researchers and scientists in the academia that now they have experts in product development, and this is, I would say, maybe the most important part of the job, of the story. So when you transfer technology, you also transfer people, and you don't have to be worried to challenge researchers, academicians to become product development specialists. But look, whatever it happens, because of course you cannot pretend that one case like Yuvo becomes the reference for other innovation processes. What I learned is that you can get all people changing the roles, all possible changes around you happening, but something that it has to be always there, and is the fact that you have to keep your goal clear. And our goal was clear from the very beginning. We transfer technology and human resources from the academia to a company with the objective to develop a business. And this was the reference against which we closed the loop. Okay? So, no distractions. I mean, you can accept changes, but in the end of the day, our goal was, out of the technology and people we transfer from the university to the company, how can we develop successful products? And the secret or the right methodology, and this is not something that I invented or we invented. I mean, there are success stories like all the giant big techs that have taught us that the starting point is the customer, is the end user. Okay? So we start always from there. So essentially, what I'm saying is that tomorrow you can come in our company and start making all the possible changes you want, changing people and make any kind of perturbation. But if the mission is always clear to everybody, from the management to all the engineers and employees, there will be a big impact of the perturbations. I don't know if it's clear what I'm saying.
Absolutely. And this is a quite sophisticated discussion we are having, because as the startup is developing its business process, as you're spinning off the concept, just the idea of spin-off. Spin-off, I remember Professor Varaldo made me do a research when I was a student about the concept of spin-off. Spin-off companies were perceived in the 80s, when the concept started, as a phenomenon to avoid. You know, how do you avoid the spinning off of your talent? And actually, for the aficionados of open innovation, the book by Henry Chesbrough is Open Innovation is indeed a story of how Xerox is unable to manage the spinning off of people from one of the most incredible places in the world, that was Xerox PARC, out of which most of the technologies within that enabled, you use the word enabled, the rise of the internet and the rise of the computer, the information technology started from. But Xerox was not able to identify the right problems for these technologies. And therefore, the people, the key scientists and technologists at Xerox PARC started to leave. And Xerox never was able to absorb and exploit the value of these incredible technologies that were generated. And from this, the inspiration of open innovation came about. So the key twist that you added to this idea that people can change a role, and of course your key scientist can become the founder of a spin-off company, but it's really like the idea is, and as you develop the company, you see people changing roles many times, but what you have emphasized is for this enable to work, this necessary enable to work, the emphasis needs to be on the mission of the company, of the project that needs to be maintained. However, we get to number 6 now, which is, at a certain point, your company is not a startup anymore. And you're not an infant. You're growing up. And the game changes as you're scaling. And we are obsessed in innovation management with the changes that you need to do in order to implement your innovation strategy as you change. And so can you help us understand what were the challenges in your case as you were scaling in running the show? What were the challenges that you faced and how did you address this fundamental enabler that was growth, that was a necessary condition to become who you are now?
I think that there is not a unique answer to this question. I mean, in our case, I would say the asset at the basis of our growth was the fact that maybe in our case this is clear, but we always know which is the problem to solve. Okay, so in the open innovation, as you said, I mean, the example that you mentioned, there is always the risk that the problem is not clear. So if you remember at the very beginning, I talked about this cherry picking operation. Okay, so you have a lot of ingredients, so many cherries, but you have to pick the right ones. And in some cases, when the challenge to address, the product to develop is not clear, you can easily face a failure. In the case of the exoskeletons, the challenge is clear. So you know exactly in the medical domain, for instance, you want to improve working capability of a stroke patients, or you want to reduce the fatigue for a worker, okay? And you know the challenge. In the wearable robotics, the problem is not in identifying exactly which is the challenge you want to face, but is that once you develop the technology, and this is, if you remember at the beginning, I said, I learned something at the end of the story, is that the product, once you reach the product, you still have to understand how to make it largely adopted. So essentially,
so you're scaling somehow in going into depth, in the complexity.
Yes.
And
so
it takes...
So essentially, you can see 3 stages, okay? So in a nutshell, this innovation journey is that the first is when you move from the laboratory to the spin-off company. So you essentially have to transfer knowledge into the company. Then you make the product, but then depending on the case, like in the exoskeletons, the product is not the final solution because you need the knowledge to support the adoption of the product. Okay? But in our case, the growth is possible because at least the challenge that we want to address is clear. It's not only one, but different challenges depending on the market segments.
So, once again, a very elegant solution to this problem, of scaling up. And in the scaling up, we see the need to cherry pick, to design a strategy, and strategy has to do with which cherry to pick, but also which other cherries not to pick. Because strategy most of the time is choosing what not to do instead of what to do. And being aware of the opportunity costs of I'm going this way, and not in a mindless way, but in a mindful way, I'm choosing this bottle and I'm not choosing this object to pick. And going in depth, you scale, almost as a consequence. And almost as a consequence, you identify the right people that need to come with you on board, the partnership that you need, the extra competences that you need, and so on. There is another, and maybe the final, considering that we have 10 minutes to conclude, there is the 7 enabler of the open innovation that you are discussing about, which is value. And the value proposition that can be the result of a technology transfer process can be super, hyper disruptive. No? It can get to the market in a very disruptive way. However, to get to the market, you need to design a business model that makes it disruptive. And you need to understand what is the value of the technology that you have. Because you might have solved the problem. And you might have picked a price.
Yeah,
but how to measure, okay, the value for your customer, if it's a final customer, or in a B2B situation, what is truly the value that your technology is adding to the business proposition of someone else, which in turn is going to translate it into someone else, and how to exploit the portion of that value which is yours, which is your technology and your know-how. This is extraordinarily challenging, and I wonder how you were able to settle for, okay, this is Yuvo's value added, and this is what I am different from my competitors, and this is what I need to be paid. Because money, at the end, it's very important.
Yes, I would say that this is the real big challenge. So when I told you that the technology is only 5–10% of the story of the innovation, the remaining 90% is how you can demonstrate that what you develop is exactly that 90% of the story. So let's do an example. If I have an exoskeleton for workers, and I say, okay, this exoskeleton reduces the effort done by a person.
So what? Yeah.
Okay, this device costs 5,000K. Okay, then you go to a company, you have to convince them to buy. Even assuming that this is the best technology, fully acceptable, fully usable, perfectly performing. But then you have to demonstrate the added value from the perspective of the business, of the buyer, from the perspective of the societal, because you want to demonstrate that there is a kind of impact on society. There is the sustainability issue that is not neglectable. But this is the real challenge. So I would say, based on my experience, do you want to make a company for any new technology you want to bring on the market?
With you, yes.
Yes, with me, yes. But don't forget this, what I'm going to say now. Majority of the things that you will struggle with will be not about technology, but will be about the barriers to the adoption of the technology into the market. So essentially, it is not uncommon that companies, high-tech companies, fail because they underestimate. Of course, we are still in time to fail. By the way, I'm not saying that you has no risk of failure. It can happen, but at least we are aware that we have to contrast the barriers to the adoption of these technologies. There are several of them, and of course, now the time is not that much, but they have to be analyzed, and you need a strategy for each of them. Barriers on affordability, barriers on identifying the added values for the buyer. For instance, calculating the return of investment in terms of money for a company that buys exoskeleton. There is not a book to demonstrate this. And maybe this changes depending on the segments. If you sell exoskeleton in one market segment, the return of investment is differently calculated than in another segment. And then, I mean, you can imagine that I'm not an expert of management or finance. I am an engineer, so this is something that I can see as a problem, but then you have to rely on experts to face this kind of reasoning. Clear?
What is next for Yuvo?
Yuvo has to focus on exactly this last part of the story. Together with its shareholders, the challenge for the next years is to push on all these barriers, trying to overcome them, and try to get the technologies really adopted in real life. This is happening, not only for you, but for many other players on the market. But this process is not easy, and it requires that you every day have a clear goal in mind, and you are not distracted. And sometimes the story is not easy to be, I mean, you don't have to give up when things apparently are not going in the right direction. And you have to be ready to change the technology if the end users ask for it. Because, I mean, this is true for all technologies, but for wearable technologies, this is a must. Because, I mean, human is not only at the center. Human wears the technology that you are developing. Maybe it will be not Yubo. Maybe there will be another company in 10 years that will be will arrive on the market later, and that will be the success one, the one reaching the success, like it happened with smartphones. But at least we are there to try. This is our spirit.
So, in order to conclude our little talk with Nicola, I think what we did today was an exercise. We never tried this before, and we tried the first time with you, and we're very pleased that you gave us the patience and your time, and you lended your time and your years to appreciate what we've done. We discussed about open innovation in a different way, and we have defined with Nicola and analyzing the case that was discussed by Nicola, 7 enablers of an open innovation strategy that Nicola really reinterpreted as he saw fit for his case. The first enabler was the application of a technology, and Nicola emphasized that technology, when it's applied to a project or a problem, is only the enabler, and the keyword enabling technology is, of course, for those of us that study management, is extremely important. The second driver was contamination, and contamination has been reinterpreted by Nicola as a federation of different complexities, and as contamination between various science and technologies field in his area come to life, managing and not getting lost in the complexities of this federation is very important. The third aspect we discussed about was the intermediation, the role of third parties in the process. And here we were in the middle between contracts and trust. So the trust that is necessary to a certain point to discuss about a technology transfer process and open innovation. Fourth aspect was the role of industrial partners, and this was reinterpreted not only as partners that were getting you to the market, but partners you were sharing the risk, the entrepreneurial risk with. So risk mitigation was brought into the light. Fifth element, the changing role of people. Extremely difficult to manage. One of the aspects where we see open innovation fail most of the time, because people don't accept the changing role. They're not able to take a step back, to let the company make a step forward. And Nicola's advice here was focus on your mission and try not to get lost in translation of the changing role. Sixth aspect was the passage from a spin-off, from a startup to a scale-up. And scale-up is absolutely successful. Scaling is extremely dangerous aspect and a very big barrier towards success. Here the advice is, once again, on strategy and on this idea of cherry picking and on the idea that you're scaling if you are able to identify the area where you want to invest and going in depth to the analysis of a solution. And this gives you the direction, and once again, it's the mission towards scaling. Last but not least, value. And the design of a business model that works for your company, which is the end, the conclusion of an open innovation journey, at least for the part that gives consistency to the story. And this is the overcoming of barriers. Barriers that are not technological, barriers that are more related to the adoption of this technology that might bring us back to circle to the first enabler that was application, but we're not going to get there, otherwise these things is going to get too philosophical. So these are the 7 enablers of an open innovation strategy that we discussed today with Nicola, and maybe, I don't know if there is time for questions from the audience, or for me it was a pleasure to discuss with you. I'm always learning new things when we discuss together, Nicola, and good luck with the future of Juvo.
Thank you very much, Alberto. It was a pleasure for me as well. Thank you. Also to the audience.
So, Monia, the floor back to you.
Just saying no questions. There are still 5 minutes if there are questions from the audience here in the room or also from people connected. I ask to colleagues if there are questions on the chat, on live chat. Let's give them just a few minutes. I take this moment just to thank again a lot Professor Nicola Vitiello and Alberto Niminin for staying with us this afternoon. It was very, very interesting, and also for me just to review this path. Are there questions? Okay, anyway, we are here also for next connections. So if somebody from the audience is interested in remaining in touch with us, we are available for this. So again, once again, thank you so much. Thank you, Nicola and Alberto, and thank you to all the people here and the people from home. Thank you so much. Bye.
Bye-bye.
Bye.
Come faccio a rinominare?
Grazie.
Rinomina.
Prima di andare via. Alberto Niminin, te sei l'uomo più social che conosco?
No, io zero, ho smesso questo, sono uscito dai social. No, zero.